Today I'm going to have a look at this solar charge controller which I bought from AliExpress. Here's the item on AliExpress, and as you can see it cost me just over $40, and I went for the 20 amp version with the optional Wi-Fi, so you can get it without anything, with Wi-Fi or with Bluetooth. And in here you can see that it does 12 and 24 volt battery banks, and down in the description here we can see it says it does DC to DC converting, and it gets a fast and accurate lock on the MPPT point within 10 seconds, 99% accuracy, peak conversion efficiency 98%. So yeah, it talks about important numbers there. Maximum PV input 100 volts, and as I mentioned, it will work on 12 or 24 volt systems. So yeah, a Wi-Fi built in. And the other thing that was interesting, of course, just here was this diagram here that suggests that you can team them up as well to the same battery, which is quite interesting. But there we've got all the various stats, and I'll place a link down below in the description so you'll be able to view these at your leisure, shall we say. A little bit further down now, this is where we talk about an app to connect via the Wi-Fi on the Apple Store and the Android Store. And this, I think, is the point that I thought this would be really interesting. In the iPhone section here, it suggests that you need to connect to an SSID such as this that starts with ESP. So it looks like the Wi-Fi chip in here is going to be an Espressive chip, possibly an 8266 or an ESP32. And yeah, that piqued my interest, so I put one of these in my basket and bought it. And let's have a look at it a bit closer now. Inside the box we have this manual, which is in English. Oh, what's that down there? Some cable crimps, I think. The solar charge controller itself, and some silica gel. Now straight away, as I've got that out, I can see I'm a little bit disappointed because, well, there's no connector here. Or is that something you remove? No, there is nothing behind there, so it's not got the RS485 that I thought it should have. The temperature sensor just dangles out of there. There's another option which is blanked off there. There's the information about the charge controller. 20 amps, 100 volts, so that's 260 watts at 12 volt or 520 at 24. It does say it is the 120D Wi-Fi model though. At the top, more blanking plates, which mean things haven't been populated, and on the left hand side, well, a hole for something or other. Interesting. And it also says patented products, counterfeiting not allowed. I've not seen that before now. But the silkscreen on the front is, well, a little bit ropey to say the least, but I'm not too fussed about that. So my first impressions, to be honest, aren't great, but let's have a look inside the unit by taking the 4 screws out of the back. And let's have a look inside, see if that comes off. I know that the sticker and the quality control on that side is making that a little bit difficult. Oh well, won't be a guarantee on this any longer. Here we go. Aha! Right, so first things first, big inductor, so it does look like it should be doing DC to DC conversion. There's that temperature sensor, which dangles about a bit, doesn't it? And up the top there we have an ESP8266, the 12F module. So yes, I wonder whether that is hackable, whether we could potentially update the firmware on there and change what it does. I will. There's also a jumper there. Let me get something to point with. There's a jumper there, which wouldn't surprise me if that's on the TX RX 3.3 and ground. A couple of screws in that. I might take that out. That is an interesting module, but actually for the solar charge controller, obviously the inductor, which I've already mentioned, the input capacitor is 100 volt, 820 microfarad. So yeah, that's where the limitation for the input, solar input, comes from, the 100 volt capacitor there, which interestingly has a small capacitor surface mount strapped across it down there as well. And then the output of the buck converter, probably the capacitor there is 35 volt, 2200 microfarad. So yeah, I mean, it looks to be reasonable. Under there, under the LCD, is an ST microcontroller, so it's all running from an STM, I can't make that out, but yeah, ST microcontroller. And yeah, the additional little module, which is just sort of grafted in there on this ribbon cable, and this awful loop holding it on. We've obviously got the USB up here as well, with its own little buck converter, probably that chip there, the XL Semi, isn't it? The 1509, with a little small inductor there, some input and output capacitors as well. So yeah, that'll be for the USB power supply. Down here there is a small 40 amp fuse on this 20 amp solar charge controller, so that's quite typical. You don't want this fuse to go, you typically want your external fuse to blow, and you fuse this at 20 amps, and this internal fuse, to as a last resort I guess, is rated for 40 amps. Yeah, pity about that though, but actually there's no connector on there, but I wonder what's on the underneath. Well, we can see, as is usually the case, there is the MOSFETs under this side of the board. There's a couple there, so they could be in parallel. Let's see, yeah, and then we've got some more under here, obviously all strapped to this reasonable size heatsink, and yeah, that's a fairly typical arrangement. So I've removed the screws from this module to get an idea and have a look at the other side. Fair bit of flux residue left over, but yeah, another XL Semi on the bottom, which presumably is the buck regulator for the 3.3 volts, which the ESP8266 requires. And yeah, I suspect those 4 points there will be TX, RX, VCC and ground, and that obviously wouldn't be difficult to trace out and check the pins on the ESP, which obviously are well documented. So yeah, there's a potential that look, there's a space there for another module on the back, isn't there? Different size. Don't know what that one would be. But yeah, the question then is the ST microcontroller communicating with the ESP and just using it as a Wi-Fi adapter, so just serial communication, and with 4 wires between the 2 modules, that's quite possible. So before I plug this into a battery, I just want to check whether this is a common positive or common negative solar charge controller. So with my meter in continuity mode, we'll just put that on the solar positive, this one on the battery positive, and yeah, we've got continuity there. So this is a common positive solar charge controller. Let's just check the negatives. Yeah, they're not connected together. So yeah, common positive solar charge controller. And in my opinion, generally either is fine. You just need to know which one you're dealing with. Probably in particular when you're using a solar charge controller in a vehicle of some description that usually has a negative ground system. So yeah, you need to be aware of that. But yeah, to my mind, either common positive or common negative is fine. So without further ado, let's get my battery connected. So let's just check. Positive on the left, hand in the way, and here's the negative. Usually a small crack when you connect this up for the first time as it charges that power, that capacitor. There we go. Did you hear that little crack as the current dumps into that capacitor? There we go. And now we can see we have something on the screen. Let me just tip this up and get a better shot. So there we have the basic screen then, a small state of charge meter, the voltage of the battery 12.7, 12.6, something like that, and the temperature here, presumably from that temperature sensor sort of dangling in the breeze there, which says it's about 22 degrees here inside the shed today. That could be the case, it's quite a warm day. No solar coming in, the load I'm guessing is on. There we go, look, there's that smiley sun, and this interesting idea of the MPPT power curve graph there showing on the actual LCD, which I think is quite nice in a way, but that seems to be suggesting that we're charging. Well, we're certainly not. It just because I haven't got any solar connected as yet, that just seems to be showing various things. I haven't checked the manual. I guess I really should, shouldn't I, to work out what I'm doing with this 2-button system. I'm just pressing things at the moment, but yeah. Well, I think the next thing is to get some solar in here and see if it's doing DC to DC conversion as the inductor inside suggests it should be. So yes, the meter on the left is showing 38.77 volts coming in. The meter on the right is now showing the battery voltage of my small lead acid battery at 13.8 volts, which yeah, it's quite a nice charge or float charge. I think it's saying that battery is fully charged on that little state of charge meter. And what's that suggesting? Is it suggesting, yeah, it says 1.4 amps on that screen. It's difficult to see because of the angle, but yeah, that's 1.4 there. So it's keeping that battery nicely charged up at 1.4 amps. At just 39 volts. I would like to check that with my clamp meter, so if I set it to the 6 amp range, check it's in DC mode and zero it out. What's coming in from the solar panel? About 475 milliamps according to this meter, and what's going into the battery? 1.2 amps going into the battery, and actually that has changed now to 1.2 amps. So yeah, that is doing DC to DC conversion. We've got 39 volts and 460 milliamps coming in, and 13.8 volts and 1.2 amps going out. So yes, definitely doing DC to DC conversion. So I've been watching this for a little while now, and my battery is being kept at 13.8 volts, which is all very good, and it's taking about 700 milliamps to do that. But what's confusing me is that the MPPT sign is showing at the middle of this LCD here, and well, I don't think we're at a maximum power point now. I think the solar charge controller is doing exactly what it's meant to do in this situation, and it's throttling the current going into my battery to maintain a voltage, and that's fine, and that's exactly what I'd expect it to do. But the LCD is perhaps a little bit misleading. For example, if I put a small load now on my battery, and this is a 20 watt lamp here, that will hopefully bring the voltage of the battery down a little bit. We should see an increase in current because the solar charge controller should adapt the solar panels to increase the current that's coming in. So without further ado, I'm going to connect this load up to my battery. And there we go, we've got a 20 watt load on the battery now, so the battery voltage has fallen, the current has increased to provide, well, 20 watts at the very least into that lamp and maintain a battery voltage. And as we can see, the panels have dropped by 1 volt to be able to increase the current going into the battery up to 2.2 amps. So yeah, that seemed to work as it should. And yeah, the MPPT sign is continually on and illuminated on the LCD, and well, to be honest, I don't think it should be. But yeah, let's see how the whole system reacts now when I remove that load again and the battery voltage shoots up. Hopefully the current should reduce and the panel voltage will adjust accordingly. Let's give it a go. Yeah, so the battery voltage has gone back up to 13.8 volts and the current being supplied has gone back to 700 milliamps, but the voltage of the panels is somewhat different to before, but it does seem to be moving around, and I think that's possibly because the sun has gone behind a cloud, but we're still supplying 700 milliamps or thereabouts into that battery to maintain 13.7 or 13.8 volts. Yeah, it's now searching around, isn't it, to and perhaps the sun's come out again and we're back up to somewhere around 39 volts. So yeah, it definitely does seem to be doing MPPT and DC to DC conversion. Now I'd like to see what goes on with the Wi-Fi, and as you can see, there is an ESP access point showing itself quite happily. So let me connect to that and see if it will give me an IP address. It said on the AliExpress listing that there was no password. It does say it's unsecured and there's no internet connection, but that should be there, and then we can use the S controller app. Okay, it all seems to be in Chinese. The device serial number, it doesn't seem to be showing any information, does it? Wi-Fi is disconnected. Oh, Wi-Fi, no, Wi-Fi is disconnected. Oh, no, Wi-Fi, yes, no, yes. The app seems to work far better on my iPhone than it does on the iPad, but first thing I need to press that cog and choose the second option down to change it into English. Essentially, it's split into 4 different areas, but as you'll see, every so often when you click a tab, you go back to Chinese, which is a bit odd, rather than English. All the information is there, however, although I found it a little bit difficult to navigate around these different menus. The other thing I noticed when I was reading the data, that seemed to work fine, but if I tried to edit any of the charging parameters on the solar charge controller, well, I'm afraid the app just crashed out on me when I tried to write them back. So there we have this sort of unbranded MPPT 120D solar charge controller, and to be fair to it, well, it did do DC to DC conversion, and it seemed to be tracking the maximum power point when it need to in my short test. But its unique selling point to me was that app and the ESP8266 Wi-Fi that's in here, and unfortunately that app seems a little bit buggy. It didn't work at all on my iPad, but it did work on my iPhone, so I'm guessing that's a permissions thing. However, once I did get it running, it was fairly buggy, and the information is there, but it's not, well, it's a bit clunky as an app, and of course you have to disconnect your phone from your usual Wi-Fi to connect to this, which has always been a bit of a bugbear of mine. So perhaps there is a chance for somebody, or even me, to have a look at the ESP8266 in here and see if there's some improvements that could be made, and start looking at how it's communicating with the main microcontroller in the charge controller. Anyway, that's it for today. Hopefully you've enjoyed this video. If you did, give me a thumbs up, subscribe down below, comment if you can, and I'll see you next time. Thanks for watching.